Hey folks, thought we'd take a look at a couple of the homework problems from section, 8.3. And in case we just don't have time to go over them all in class. So this is the beginning of some trigonometric integrals. Good, clean fun. So the first one that we'll look at is number 27. And we're only going to do two, or I'm only going to do two, 27 and 35. So number 27, you were asked to integrate cotangent to the fourth x dx. And the first thing I would do is rewrite the cotangent to the fourth as a cotangent squared times a cotangent squared. So what I'm going to do real quickly is, let me grab my notebook here. And just to remind you that well, we have some identities. I told you there some identities would be very helpful for us here. So the first identity, or the main identity that I'm going to review for us right now, is that 1 plus cotangent squared x is equal to a cosecant squared x. Or cotangent squared x is equal to a cosecant squared x minus 1. Now I'm going to use this identity. If you look over here for one of the cotangent squareds, I'm going to substitute cosecant squared x minus 1 for well, it doesn't matter, but one of these cotangent squareds. So continuing on, let me come back over here and there, did the substitution, cosecant squared x minus 1 for the cotangent squared. And then in my next step, it is what it is. You just kind of, distribute the cotangent squared. So there's your cotangent squared getting distributed. And then I will split it into two separate integrals. So I'll actually show that step of splitting it into two separate integrals. And then at this point in time, I think we're set up for a u substitution. In the first integral, we will let u equal cotangent x, then du is a negative cosecant squared x dx. So I'm going to do a u sub here. This is u, cotangent x, and then du, look at that. Du is negative cosecant squared x dx. So this integral looks like it's going to be pretty easy to take care of now. Now this integral here, once again, I'm going to take advantage of, let's come back and look at it one more time. I'm going to take advantage of this identity, and I am going to substitute cosecant squared x minus 1. I'm going to put that in there for the cotangent squared x. So after my next step here, I take care of my u sub, and see that gives me the negative integral u squared du minus, and I substituted cosecant squared x minus 1 for the cotangent squared x. And now it should be a pretty straightforward problem to finish. We know the antiderivative of, u squared is going to be a 1/3 u cubed, so it'll be a negative 1/3 u cubed. And then antiderivative of cosecant squared, well, antiderivative of cosecant squared is cotangent. Kind of friendly. And then the antiderivative of 1 is x. So here we are, negative 1/3 u cubed minus the negative cotangent x minus x plus c. I'm going to resubstitute cotangent x for the u. And at the same time, I'll distribute the negative sign on through. So that's the final answer. And hopefully that's what you have for number 27. So the next one I said we'd look at is number 35. So here we are, number 35. You were asked to integrate tangent cubed 4x dx. So, my first step, I'm going to rewrite tangent cubed as tangent 4x times tangent squared 4x dx. And then, let me come back to my handy-dandy little notebook here. And just to remind you of, let me get a new sheet, of the identity we're going to use here. Here the identity that we're going to look at is 1 plus tangent squared x. Well, we know that equals a secant squared x. So that tells us that a tangent squared x is equal to secant squared x minus 1. And that's what I'm going to do. I'm going to take where I have this tangent squared 4x, I'm going to use this identity. Tangent squared 4x is going to be a secant squared 4x minus 1. So continuing, substituting the secant squared 4x minus 1, substituting that in for the tangent squared 4x gives me this friendly looking problem. My next step will be to distribute the tangent 4x. So now that's what the integral turns into. And then my next step is just to split it into two separate integrals, just to kind of see what's going to happen. Kind of looking ahead here, this first integral here is going to be handled by a u sub. You know, if we let u equal tangent, we know the derivative of tangent is a secant squared. So it looks like a u sub will take care of the first integral. On the second integral here, well, let me just remind you one more time. I'm going to come over here to my handy dandy notebook again, that we know the antiderivative of tangent x. We know that integral is the negative natural log absolute value of cosine x plus c. So since we know that, the integral of tangent 4x dx, well, that should be a negative 1/4 the natural log absolute value of cosine x plus c. Yeah, we don't know absolute value there. Absolute value here. So this last integral, look how easy it's going to be. There it is. Negative 1/4 natural log absolute value of cosine x. So let's come back over here and continue. Here's our u sub. U is going to be tangent 4x. du is 4 secant squared 4x. So 1/4 du will take care of the secant squared 4x dx. So doing the u sub, and again, we know the antiderivative for this. You know, we just did it over here on you know, the handy dandy little notebook. It's right there. So taking this, putting it in for here, we should have 1/4 the integral of u du. That's our first integral here after the u sub. And then minus that negative 1/4 makes it plus 1/4 natural log cosine, absolute value cosine 4x plus c. So now it's pretty friendly. We know the antiderivative of u is a 1/2 u squared, so we have a 1/8 u squared. And substitute tangent 4x in there for u, and this is what we get as the antiderivative. So that's it. That's it for number 27 and number 35. And hopefully you got those. And this quick little screencast was just verifying what you did was good. That's it. Thanks for watching.